Hello and welcome to Calculus Tutorial. We are going to keep taking a look at extrema today, but a slightly different kind. We have mostly been focusing on relative extrema so far, and that is the highest and lowest point relatively, not necessarily where the graph can keep going up forever and ever, but your hill and your valley. And so here we have a valley, that is our relative minimum, and here we have a hill, that is our relative max. But of course, the graph does go down forever and up forever still. We're going to talk about a different kind of extreme value, a global or absolute extrema. That is the actual highest point or the actual lowest point for a graph. And one slight thing has to change with the way we word these problems, is you're going to find the highest or lowest point on an interval. So you can see how this graph goes up forever and it goes down forever. So we can't really find the actual highest or lowest point that goes on forever, unless we truncate this graph and give it endpoints and say it only goes from -4 to about +9. And if we stop it there at the endpoints, then we can find the actual maximum and the actual minimum if we cap it off at certain places. That is what's called the global or absolute extreme value or extrema. Now, to do this, there's a couple of things that you have to keep in mind. A relative min could still be the lowest point. A relative max could still be the highest point, and so we have to find those. But there, as you can see on this one, there are two other possibilities. This is obviously the lowest point. That is the end point. It's not quite clear if this is higher than our relative max or not, and so what we have to do is check these possibilities. It could be a relative min or a relative max, or it could be one of the endpoints. And so the only difference or the extra thing we have to do now is check our endpoints and compare them with our relative extreme values, and that will give us the global or what's called the absolute minimum and maximum. So one slight extra thing to do is to check those endpoints. All right. Let's take a look at an example of how this works. And so I took away our graph here, so you can't see what the answer is right off. So here we have a function, it's a cubic, and we have an interval now from 0 to 4. So we're only looking from 0 to 4, and we're going to find the maximum. We'll probably also find the minimum in this case, but let's only be interested in the maximum. Now, the process starts out the same. It could be a relative max, so I have to find the relative max. So that is the derivative, which will be x squared minus x, it looks like -6, which I believe factors into x minus 3, x plus 2. So for my two x values here, I have to check 3 and 2. I'm sorry, -2. So check those two here. -2 will be over here. 3 will be over here. So check a -10, say. So we have negative, negative, which means this will be positive. Easiest number in here is probably 0. So that will be negative, and that will be positive, which gives us a negative. And check a number over here like 10, positive, positive. So it looks like -2 is going to be a relative max, and +3 is going to be a relative min. So if we're really just looking for a maximum, we know it's not going to be a relative minimum. So we have to check f at -2. That could be our highest point. But like we said before, it could also be one of these endpoints. It could happen at the beginning at 0, or it could happen at 4. We're not sure, so we have to compare those with the relative max. F at 0 and F at 4. Now I will say one thing. If you want to, for your absolute maximums, you can actually skip this whole step if you simply test F at 3 as well. It will obviously be smaller than the others, or at least most of them, so it's not going to be a max. But if you don't want to do your sign chart, you can skip it and just include F at 3. But now we simply have to plug those numbers into your original function and see which one is the biggest. That will give us our relative, or sorry, not our relative, our absolute max. So to do that, I'm going to bring up my calculator since it's got fractions. I've got my function plugged in. Make sure you're doing the original function, not the derivative. I'm not interested in the slope. I want the actual y value here. And so then I'm going to go to number, and I'm going to plug these numbers in. So first, -2 gives me 7.3, and then 0, and then 4. And we should know I don't need to, but I'm going to 3. Alright, so those are my 4 values. And looking at them, F at -2 is the largest. So that is going to be my absolute max. It happens to be a relative max as well. And the other ones are not. The absolute minimum is F at 3, it looks like. We weren't trying to find the absolute minimum, but there it is. So let me type those in. 7.3. Looks like that's repeating. 0, -10.6 repeating, and -13.5. So this one is the max, and this one here is the min. So the key here is that after you find your relative minimum and maximum possibilities, you also have to check them against these two here, the endpoints. And the biggest one is your maximum, your absolute maximum, and the smallest is your absolute minimum. And it could be any of these. It just happened to, the relatives were higher this time than the endpoints. All right, it's really important that we see the difference between relative extrema and global extrema, because you will have to find both, and you want to make sure that you understand the difference between them.